All right, I'm just going to work through the weak base strong acid question that I am going to give you on the slides, and because I can't be there in a face-to-face meet tomorrow and Wednesday, I'm just going to record this now. So I have got 0.0255 moles per litre methanamine. I've got 15 mils of that, and I've been given the pKa for the meth, I don't even know how you say this actually, the conjugate acid of methanamine, and that is 10.7. So what I'm going to do here is I'm going to do the first point, which is the point at the start of the titration curve, so it's just the pH of this weak base here. So to do the pH of a weak base, I need to write an equation for the weak base reacting with water. And then I need to write a Kb expression. So that's the products over the reactants. I'm not going to put in the states. And then I need to substitute into this equation here and rearrange to solve for the OH minus and therefore the pH. So first thing, I've only been given the Ka or the pKa, so I'm going to work out the pKb, which equals 14 minus 10.7, and that equals 3.3. And then the Kb equals 10 to the power of the negative 3.3. And that, I'm just going to do that on my calculator. So shift log negative 3.3 is 5.01 times 10 to the minus 4. Okay, so that little bit of work there is for my Kb, so I can now substitute that in there. Just separate that off. And I'm going to make my two assumptions. One is that these two are equal, and I'm going to call them x and x, so that gives me x squared. And my last assumption is that because it's weak, this base has literally not dissociated at all, or essentially I should say, so that gives me 0.0255, and if I rearrange that and solve for x, I'm just going to grab my calculator, 0.0255 square root, so equals, so x equals 3.57 ... times 10 to the minus 3. And I'm going to negative log that to give me the POH, which is 2.45, and I'm going to subtract that to give me the pH, so 14 minus answer, which gives me 11.55 or 11.6 to 3 significant figures. That's my point 1.